Hello students, hope you are following the chapter from the starting. We discussed about state matter and we discussed about the different ways of classification of matter, and after that we discussed about the laws of chemical combination, which is followed by the mole concept. Now we are going to discuss about the different methods of expressing the concentration of a solution. Say suppose you have taken 1 tablespoon of sugar and you added that to some amount of water. You want to express the concentration of the solution numerically. So to know about how to express the concentration numerically, we have to go through this particular video. So let's start. Now let's understand the different methods of expressing the concentration of a solution. In that we'll see what is meant by solution, what is a solution is, and what is meant by concentration of a solution, and what are the different ways in which we can express this concentration of a solution. Okay, so let's start. Concentration of a solution. Okay, so in this picture you will see I have taken water, that is solvent, and this is salt that is added to this water, and after addition, if you mix, you will get a homogeneous solution. So homogeneous mixture you will get. So this homogeneous mixture is actually a solution. Okay, a solution is a homogeneous mixture of 2 or more than 2 components. Okay, so here we have only 2 components, and the one which is present in the smaller quantity is known as solute. So here salt, the NaCl is solute, and the one which is present in the major quantity is known as solvent. So here water is the solvent. Okay, a solution is a mixture of solute and solvent. Okay, so let's understand what is meant by concentration of a solution. When do we say that a solution is concentrated? The more solute in a given volume of solvent, the more concentrated is the solution. So here after adding the salt to water, I will get a salt solution, right? So if I add more water, I will get more concentrated solution. So say suppose this is 100 ml of water I have taken in a glass, and here I added 1 tablespoon. Okay, so this is one salt solution I have, and second salt solution I am preparing separately, and I have taken same volume of water. I have taken 100 ml of water only, but instead of say 1 tablespoon, if I take 5 tablespoons of salt I have taken, I added that salt to water. Okay, so which solution is more concentrated? Is it the one which is formed from 1 tablespoon, or the one that is formed from 5 tablespoons? Which is more concentrated? Here the one that is formed from 5 tablespoons is more concentrated, because it contains more amount of solute in a given volume of solvent. The volume of water I have taken same, that is 100 ml I have taken. So which one is going to contain more amount of solute? Obviously the 5 tablespoon salt, that is going to contain more amount of solute. Okay, then we say that this is more concentrated, and we say that this is less concentrated. Okay, the concentration is basically the amount of the solute present in a solution. Okay, so let's discuss more about it. Yeah, here I have taken 1 tablespoon, added to a cup of water. I have taken 3 tablespoons, added to the same amount of water. So obviously the second one is going to be more concentrated, since it contains more amount of solute in a given volume of the water. Okay, so on a qualitative basis, the solution can be classified as dilute and concentrated. Okay, so dilute solution is the solution which is less concentrated, and the concentrated solution is what? The one which is more concentrated. So here I can say this is dilute solution, and I can say this is concentrated solution. Okay, so this is on a qualitative basis. So but this qualitative basis does not provide the required information or enough information about the concentration of solution. So we have to represent that solution, the concentration of solution in a numerical way, that is in a quantitative basis. Okay. So in a quantitative basis, the solution can be expressed, the concentration of solution can be expressed in many ways. So let's start. One is the percentage concentration. The percentage concentration. Okay. So the percentage concentration can be weight by weight, it can be weight by weight, it can be weight by volume, it can be volume by volume, or it can be volume by weight also. These are the four types of expressing the concentration as a percentage. Okay. So let's discuss about these four. First is weight by weight percentage. Weight by weight percentage, that is defined as the mass of solute in grams divided by the mass of solution in grams into 100. Okay. So here this is the mass of solute and this is the mass of solution, and if I multiply it with 100, I will get the weight by weight percentage. Here I am taking mass, weight, here I am taking weight, so it is known as weight by weight. Okay. Say suppose if I add 1 gram, say if I add 10 gram of NaCl to the 100 gram of the solution, 100 gram of the solution. So what will be its weight by weight percentage? I added 10 grams, so 10 divided by, I added this 10 gram to the 100 ml, 100, the mass of the solution is 100 grams. Okay. So into 100, so 100 will get cancelled and I will get 10. So this 10 represents the concentration of the solution in terms of the weight by weight percentage, right? The mass of solute added divided by the mass of solution. Remember, this is mass of solution, not only the mass of solvent. We have to take the mass of solute plus mass of solvent, that is the mass of solution. Okay. So don't confuse you. And let's come to this weight by volume. Okay. So here also the definition you can easily understand. The only thing is this is weight by weight. So the mass of solute you will take, instead of weight you will take volume of the solution. Okay. That is in ml. So if I take 10 gram of NaCl, if I add it to 100 ml of the solution. Okay. So what will be its weight by volume percentage? That is, I added 10 gram of solute to the 100 ml of the solution. So 10 by 100 into 100. How much I'll get? I'll get 10. So 10 represents the weight by volume percentage. Okay. So here I need to take mass in grams and I need to take the volume in milliliters. Okay. So don't forget this. So let's come to volume by volume, that you can easily guess. Volume by volume is what? It is the volume of the solute by volume of the solution. Okay. So volume of the solute in ml divided by the volume of the solution into 100. Okay. Yeah. Say suppose if I give you, say I am adding 10 ml of water, 10 ml of water to some other solvent, and I am getting a solution, and that solution is, say suppose 200 ml of solution I form by adding the 10 ml of water to something else. Okay, some other solvent. So what will be its volume by volume percentage? The volume of solute you added, that is 10 ml divided by the volume of solution is how much? 200 into 100. So 102 will get 5%. So this 5% is the volume by volume percentage. Okay, and the last one is the volume by weight. Volume by weight, that is the volume of solute divided by the mass of solution in volume you will take in milliliters and mass will take in grams. Okay. So in this way the percentage concentration can be expressed in 4 ways. Okay. So depending upon whether mass of the solute or volume of solute is given, or mass of the solution or volume of the solution is given. Okay. So from that, even for the same solution, you can express the concentration in 4 different ways. So this is about the percentage concentration, and let's move to the next method of expressing the concentration. Yeah, that is molarity. Okay. So molarity is one of the very important the way of expressing the concentration of a solution. So the molarity, it is denoted by capital M. It represents the number of moles of solute in 1 liter of solution. The number of moles of solute in 1 liter of solution. Say I have 1 liter of solution. 1 liter of solution I have, and the number of moles of the solute in this solution if I know n, okay. So the number of moles divided by the volume of the solution will give us the molarity, okay. So here I have taken some solute and I added this to some solvent and I got this solution, okay. So the concentration I want to express in terms of molarity. How can I express? The molarity is equals to number of moles of solute divided by the volume of solution in liters. We have to take the volume of solution in liters. So if you take in milliliters, like the formula will be similar, but the only thing is the number of moles divided by the volume in ml into 1000, okay. So be careful about volume. Most of the time they give in terms of milliliters, so it's better if you remember this formula in terms of milliliters, okay. The number of moles by the volume in milliliter into 1000. So the number of moles you can calculate, that is the mass of the solute by the molecular mass of solute. The mass of the solute, if I represent by m, divided by, say, the capital N represents the molecular mass of the solute into volume in ml into 1000. This is the formula, the elaborate formula for the molarity, okay. So by using this formula you can calculate the molarity of the any solution, okay. So let's discuss more about it. The molarity, it is denoted by capital M. Say I want to prepare 1 molar solution. So that 1 molar solution contains 1 mole of solute in every 1 liter of the solution. So we know that the molarity is equals to number of moles. So you are taking 1 mole. So 1 mole divided by 1 liter. So the molarity will be 1. Okay. It is known as 1 molar solution. Okay. So suppose if I want to prepare 1 molar salt solution I want to prepare. 1 molar salt solution I want to prepare. So how much amount of NaCl I need to add? That is 1 mole you need to add to 1 liter of water, right? So 1 mole of NaCl weighs how much? 1 mole of NaCl, sodium is 23, chlorine is 35.5, so you will get 58.5 grams. So if you take 58.5 grams of salt and if you add this to 1 liter of water, you will get the 1 molar salt solution you can prepare, okay. And the molarity is expressed in moles per liter, that is capital M. And if you understand, the molarity is a temperature dependent term because it involves volume term, right? So molarity is equals to number of moles by volume, right? So but because this volume of the solution is dependent upon temperature, okay. So if I vary the temperature, the volume is going to be vary. So if volume varies, then obviously molarity is going to be vary, because though the number of moles remain constant, that volume is a function of temperature. So that's why molarity is temperature dependent. It's a very important thing. Temperature dependent, okay. So this is about molarity. What is molarity and how to find the molarity of a solution? So to find molarity, you need only two things. You need to know two things. That is the number of moles you need to know, and volume of the solution you need to know. And number of moles you can easily know. You can calculate if you know the mass of the solute. So basically you need only two things. That is mass of the solute is added and volume of the solution. So if you know these two things, you can calculate the molarity of any solution that is given to you, okay. So this is about the percentage composition as well as the molarity. These are the two ways of expressing the concentration of the solution, and the remaining different ways we'll see in our next part, okay. Now we'll see a video demonstration on the concentration of a solution and about the molarity. It is one of the method of expressing the concentration of the solution that we discussed just now. That is the concentration of solutions, molarity. So if your tea does not contain enough sugar, what you will do? We add sugar to increase its sweetness. That means we are increasing the sugar content in the tea. right? So in chemistry point of view, the concentration of a solution is nothing but the amount of the solute dissolved in a known volume of the solvent. So here in this video you can see the different amounts of the solutes are present in a given amount of the solvent. Here we have more amount of the solute and we have the less amount of the solute. So that's why here the color is more intense, here the color is less intense. So if it's more amount of the solute is present, then it is more concentrated. So in chemistry, in laboratory, most of the chemicals that we use are solutions. So it is very important to understand the concentration of the solutions. Okay. So these 4 solutions are having different concentrations. So we have 3 different ways of expressing the molarity, the molality and normality, but in this video we discuss only about the molarity, the concentration of, the way of expressing the concentration of solution. So we know that 1 mole is equals to the Avogadro number of particles. Avogadro number of particles, the 6.023 into 10 power 23 number of particles. So the mass of these many number of particles is equals to the molar mass of the substance. Molar mass of the substance. So molarity is defined as the number of moles present in a given volume. So number of moles of a solute is what? It is the mass of the solute by the molar mass of the solute. So if you take 1 mole and if you dissolve it in 1000 ml, that is 1 liter, will get 1 molar solution. So molarity is equals to number of moles by volume of solution, which is expressed where the units of molarity is mole per liter or mole per decimeter cube, and this molarity is denoted by capital M. So number of moles per unit volume. So let's prepare a 1 molar solution, 0.1 molar solution of nickel chloride, NiCl2 solution. So 0.1 mole of NiCl2, we have to calculate the number of moles, that is equals to its molar mass. The mass of NiCl2 we have to take is equals to the molar mass into the number of moles. We will get the mass of the nickel chloride that we have to take to prepare 0.1 mole of its solution. So the value comes around 12.96 grams. So we have taken 12.96 grams exactly, and we put this much mass of the nickel chloride in a beaker, that is 1 volume of the beaker, that is 1 liter, 1000 ml. So we added some amount of water and then we allowed it to dissolve completely, and after that what we'll do is we'll add the remaining volume of the solvent, that is equals to 1000 ml. Yeah, now we make it 1 liter. So 1 mole is now present, 0.1 mole is now present in 1 liter of the solution. So its molarity is 0.1 molar. So here the 1000 ml is actually volume of the solution, not the volume of the solvent. Okay. So this is about the molarity. So students, in this particular part we discussed about the 2 methods of expressing the concentration of solution. One is the percentage concentration, the other is molarity. So in our next part we will discuss about the remaining ways of expressing the concentration of solution. So stay tuned to know more about the methods of expressing the concentration of solution.